Okay, so we have another equation here where it's a 3 by 3. And we're going to go ahead and solve this using the calculator, using that row reduction method. And so the first thing I'm going to do is I'm going to write this guy as an augmented matrix. So the coefficients of the variables, and I'm going to double check everything's xyz, xyz, xyz. All the x's, all the y's, all the z's, and all the constants are in columns. So I'm going to go ahead and input this matrix. I already got a 3 by 4 set up, so I'm going to actually just overwrite the one that's in there. Enter, enter. I know I'm going to put in all my coefficients. So 1, 1, 1, and then 2, so that worked out nicely. And then I have 3, 2, 1, 3, and then I have 6, 4, 2, and 6. So I'm just pulling all the coefficients, and then the very last column right here on the far right is the 2, 3, 6, which is all of the values that the systems are equal to. Okay? I'm going to do a quick double check just to make sure, because the calculator is doing the work for you, so you don't want to input anything that's incorrect. So I go 1, 1, 1, 3, 2, 1, 6, 4, 2. I'm good to go. I got to quit out of here. Remember, the calculator's a little funky sometimes, and I'm going to go ahead and second matrix. And under math, and remember what we're going to be looking for is RREF, reduced row echelon form. And I get to RREF, which is B in this one. Hit enter, and then I'm going to select, so I go back to second matrix. The information that I inputted was matrix A. Hit enter, and this is what I have. So we look at the PowerPoint on the right hand side, right, matches what we have. And so technically the system, I have x minus z is equal to -1, y plus 2z is equal to 3, and 0 is equal to 0. So in this situation, now remember we have 3 lines that are crossing, and I want to know where all 3 cross. And what this tells me, though, is because the 0 is equal to 0, just like if they were 2 lines, we have infinitely many solutions. And so if you'll notice here, these are all, so if we look at the 2 lines at the bottom, one is just multiplied by 2. So we have 2 lines that cross, there's infinitely many solutions. It is a dependent system. So these are just special cases that we could see. And then we'll talk about where we get one specific solution and what should happen. And right away I know that there's a problem because I don't see the identity matrix. And so when you don't see the identity matrix, you know that there's a little bit of a problem.